Hello and welcome to this Artful Design TV coding tutorial. Today we're going to be creating a very basic but very precise music sequencer using Chunity, which is the Chuck audio programming language in Unity. My name is Wang. With me is Kangwoo Kim. Hey Kangwoo, how you doing?
Hello, I'm doing very well, thank you.
Alright, so for us to give you an idea of what we'll be working towards, let's go ahead and run kind of what the finished demo would look like and sound like. What we're going to have here is a chicken sequencer, or a chickencer. And in this very simple sequencer, it's barely a sequencer, we can actually select individual chickens and change their height. This actually changes their volume. And you can also change their size in terms of making them bigger or smaller in the horizontal direction. And that changes the rate in which the sound is played back. You can have, minutes of fun with this. Alright, so that is that's the goal for today's tutorial. To do this, we will provide an audio-driven way to synchronize the audio, the graphics, and the interaction using Chuck's precise, strongly timed programming paradigm with the graphics and input coming from Unity. We'll show you how to put these things together and also some best practices for specifically for managing time across the audio synthesis and the real-time graphics and really getting data back and forth and figuring out how to really control time in a precise, smooth, and stable way. Right? So you can find code for this as well as links to other coding tutorials from Artful Design TV below. All right, Kangwoo, shall we get started?
Yes.
So to save us some time, we've actually have here a kind of a pre-populated starting project. And just to give you a sense of what we've done so far, we've imported a Chunity as well as a free asset from the Unity asset store called Meshint Free Chicken Mega Tune Series. That is and you can find this free again on the Unity asset store along with Chunity, which is Chuck for Unity. We've imported these into our assets. We have created a new scene called Chicken Scene for the chickencer. We've put two things of grass here from the Meshint Free Chicken Megatune series. We've also basically repositioned the light and added a ground. Which is just a 3D model that's actually a plane. And so, let's see, anything else we've done here? I think that's all we've done up to this point.
Other than putting the material for the ground, right. That's it.
And we also created just a material just to actually be able to give that both its color and its reflection. So let's get started now with actually just getting getting Chunity set up and also getting some graphics to show. So I guess the first thing is we're going to create a Chuck main instance.
So it's an empty game object.
We'll call this the Chuck. And we're going to go here into add and do Chuck main instance. And once you do that, you can actually see all these other properties show up in the inspector. And what's next?
Next, we should create a script to contain all the information we want to compute.
And what shall we call the script?
Chicken sequencer.
How about a chicken sequencer? All right, and I'm going to open up the chicken sequencer. And in this case, you can see it's our standard C# file with the start and update methods. And so today, in order to, because we have to get through a fair amount of code, which we'll also provide, we will actually copy and paste in chunks of code, but in chunks and also in a particular order. So we can actually see, just get an intuition of how this kind of, how this particular sequencer is architected in terms of the audio and the graphics. And we'll say here there are many different ways to do this. Right, there are many ways. There are many different kinds of sequencers you can make, and this is just one of many ways that you might do that. But we do want to show you how the audio and the graphics actually can work together. But we'll copy and paste to save us some time. So the first thing I'm going to do is, here's some code that's already been written. We're going to go ahead and copy in basically something for the chicken prefab. All right, and what we're going to be doing is that this is actually the prefab coming from our free Chicken Tune Megatune series assets, and we're going to be generating a number of them into and store them into an array. So here I'm going to just go ahead and copy all of this over, and let's go ahead and just briefly look at what we're copying into here. So we basically have an integer that's the number of chickens. We have basically a chicken array that's going to contain references to our various chickens. That's the big chickens. And then we're going to have something that's going to tell us about the way we space them when we draw them. And we're also going to have the playhead, which is another game object. That's going to be the smaller chicken running across the grass. And in the start function, let's see, am I missing anything, Kangwoo?
Yeah, I think we can proceed.
Can we safely proceed for now? Okay. So there's a bit of graphics to initialize. So we've actually put all of the graphics initialization in the init graphics function, and we're now going to just populate this here now, right after start. And before we call this function, let's get a basic sense of what it does. So here we're going to actually allocate the array of chicken game object references. That's going to hold our references to our chickens. We are going to figure out the offset that we're going to need in order to, this is actually the X offset with which we're going to position each of these chickens. And we're going to loop through the number of chickens we have, which currently is 4, by the way. And for each chicken reference in the array, we're going to instantiate a new game object from this prefab, and we're going to actually put it at this position. And you can kind of see this is keyed off of both the index to this array as well as the chicken spacing, which we have up above. And I don't think we're in this case, just because we're oriented the camera, we're actually going to just rotate it 180 degrees, so it's facing the camera by default. And similarly, we're going to create another game object that's also using the chicken prefab, and as you can see, we are going to position this a little bit towards the camera, and we're also going to make it smaller. This is again the smaller chicken that's running across the grass. And this here, should we go ahead and actually do this, or should we go ahead and do this now? Or should we come back to this? This is the selector. This is the thing that appears over the head of the chickens.
Right.
Maybe for now, let's not worry about this.
Yeah.
We'll even come back to this animator. So this is all we have right now in terms of initialize graphics. And we're going to just call this from inside the start function. So this is what we have so far. Let's go ahead now and also initialize the audio, right?
Yep.
So here's initialize audio, and what we're going to do here is we're going to run an external chug program from here as part of this audio initialization, And we're also going to put some hooks into that chuck file via Chunity using this. So for this, we're going to need a couple of other things. But first, let's go ahead and just call init audio. I don't think these actually there's any dependency here, so we can actually call them in whatever order we'd like. And then we're going to copy and paste a bit more out of this code. Let's go ahead and now copy the audio section and put it under the graphics. All right. How are we doing, Kangwoo?
Yeah, I think maybe we could explain a bit about float syncers and int syncers that we use.
Oh, yes. So in this case, in the init audio, we actually have this concept of a chuck float syncer and a chuck int syncer. And what these do is that they are ways to get at the values of variables inside the chuck program. And those variables will have been designated global in the sense that they're actually are something that Chunity can recognize, and also it can actually get at those values. So in this case, we can actually, for example, get the playhead position, which is going to be computed inside the chuck program, right? Anything else to add?
And for float syncers and int syncers, we must initialize like the code in the script in order to make it work.
So shall we go ahead and maybe go to the code? And in this particular file, which is blank right now, we're going to copy in some chuck code. But before we proceed, let's briefly think about how we're going to do this. And this is the really important part as far as timing is concerned between audio synthesis in chuck and the way that it's actually talking to and synchronized with the graphics and the interaction on the Unity side. The most important thing to realize and to remember from this tutorial is that regardless of the kind of sequencer you're making, it's generally a good idea to put the timing synchronization in the chuck side. So if you're doing some kind of a drum machine, for example, or some other kind of step sequencer or a grid-based or non-grid-based sequencer, whatever it is, chuck is built to give you ultra-precise timing, right? And so chuck ensures that you can always talk about time in a sample synchronous, precise way. So the audio timing is not going to drift. There's not going to be jitter. And the idea is that we're going to compute anything that's time related in chuck, including the main music loop, and also use chuck to update the position of the little chicken, that's the playhead, that's actually running across the screen. But since the playhead needs to be precisely synchronized to the sequencer, we're going to do that part really from chuck as well. So let's go ahead and get to the step where we can see the chickens as well as a little chicken running across the screen. And in this case, I'm going to copy a few more things here. Let's go ahead and copy these lines of code. And I'm going to go ahead and save this as well into Chunity tutorial chickens are 2020 assets, and we need to put the streaming assets folder. So let's do a new folder. And we'll put it right in there. We'll call this our chickensir.ck. And note that this here's the number of chickens. And this is the one part you have to hard code a bit, at least in our simplistic tutorial here, between the chuck side and the C# side. Right? We could make this more complicated and have one side notify the other of the number of chickens we have, but here we have it so that you just have to make sure that this number is the same as the num chickens at the top of your C# file, right? So with that, we can see that we have a notion of basically a beat. That's actually the duration between chickens. And we also have an update rate, which we'll explain in a moment, as well as this position increment. Now, here, are basically our global integers and float from the chuck side. And this is actually what's connected with the float and int syncers when we actually do the initialization on the audio, right? Let's see, what's next, Kangwoo?
Yeah, maybe we can create some sounds.
Let's create some sounds.
By copying the sound buff code.
So we're just going to play something that's really easy to play sound, and that's why we're getting Homer Simpson going dope, because that's actually just a special sample that's built into Chuck just for easy testing. And of course, you can play whatever sound you want. You can generate your own sound. You don't have to use sound buffs. Here's just because it's easy. You can actually create your own physical models, or generate your own synthesizers and actually control those with your sequencer. But in this case, we're just gonna basically make some sound in a controllable way. So we created this sound buff and actually loaded the special dope sound, that's Homer going dope, into this buffer. We have a main loop here, which I'm gonna now copy in. And this main loop, basically, it goes like this. We're going to play the thing. We're going to reset the position to 0. That's reset the position of the sound buffer to 0, which starts it playing from the beginning again. We are also going to set whatever the current chicken number is. Remember, currently we have 4 chickens, and we're going to be advancing that number. We're going to set that, update that to the playhead position. We're going to use Chuck's time advancing mechanism to say, let's wait for a beat worth of time to advance. Remember, in this case, it's 400 milliseconds. So it's really waiting in this kind of a discrete grid to go from one chicken to the next chicken. And then we're actually going to, once we are past this amount of time, we're going to then increment our current chicken index. But then we're like, hey, if this actually is greater than or equal to the number of chickens, we need to wrap this back to 0. Right? So this is the generally what we'll be doing. In fact, actually, Kangwoo, shall we try running this?
Yeah.
Let's see what happens. I mean, how could this not work? What happens when we run this? Will this even run?
We should first create an empty game object for it to
for the chicken sequencer itself. So create empty. And this is the chicken sequencer. In fact, we'll just call this the chicken server here. And in here, we are going to drop this in here.
And add Chuck sub instance.
So add a Chuck sub instance.
Yep. So wherever you have a Chunity script running, it should have a Chuck sub instance.
Great.
Yep, and then we'll attach the main instance, the Chuck.
The Chuck. So we're going to attach that to over here in the Chuck sub instance. Let's see, boom. We're going to attack a few other things. For example, this prefab in our chicken sequencer script. So in that case, we're going to go and find the prefabs inside our Mesh and Free Chicken Megatune series and go tune chicken. That is what we want. And that's going to be, drag it over here to the prefab. Now, with that hooked up, let's see, anything else before we try running this?
How could this not work?
How could this not work? Let's try this. What will we see?
Okay.
Okay, we see, don't see things moving, but we see the 5 chickens, the 4 chickens and the little chicken, right?
And we also hear the dope sounds.
We also hear the dope sounds. So this is good. This is a good sign. We actually hear audio going, but right now let's try to hook up the graphics. So one thing we can do is now it's time to actually make something move. So in this case, let's see. We are going to, what is this, update name? Okay, we're not going to do that just yet. We're going to copy and paste this part of the code, and we'll explain this as we go. into update. What this is doing is ultimately this is getting that Chuck float syncer that we set up right here, this playhead position, and we're using this get current value to get at that particular value from Chuck into our C# side. This is very useful because now see we can actually get at the values of things in Chuck, and we're going to use that to translate this the playhead, and so that's the little chicken, right? So
Yes.
and we do a little bit of math here with the offset, given how many chickens we have and the chicken spacing, so we know basically what the range of motion is. But keep in mind this current value is going to go from 0 to num chickens minus 1. So it's a kind of a normalized value between 0 and really the number of chickens minus 1. And then this, we're just doing a little math here between offset and then this chicken spacing time this to map that onto the where it's supposed to be running. So if we run this, I wonder what will happen. Anything? Great. Now we have the little chicken, the playhead, actually visualizing the steps in the sequencer, right? And that's mapped to each chicken, right? So this is nice,
Right.
but remember but there's something that's missing here, Kangwoo.
Yep, it's not going to teleport, but it's going to run, right?
Right, exactly. So right now it's teleporting. So how do we get this to run smoothly, right? So far we're doing, a lot of things are going right for us. One of them is that we actually have this very tight kind of a Homer Simpson going dope in the sequencer. And by the way, if this were a drum machine, you can make this as tight as you want in terms of timing, and it's not going to drift just because we're doing this from the audio side, right? But the trick here is to do that and to have smooth running graphics, and in some sense almost hide the fact that this is a discrete step sequencer. So how do we do that? Well, let's go back to our Chuck script. And in here, remember this playhead pause, right? And also this position ink that we haven't used yet. We're going to copy just a bit more code from here. We're going to copy a function called playhead position update. I'm going to put that down here. And also, it's a function that's meant to be sporked in Chuck, which means this is going to run concurrently or in parallel with the main loop here. So it basically says, hey, you start up a parallel shred and do things concurrently with everything else. So inside here is another infinite while loop. And in this while loop, what it's going to be doing is it's going to be computing at a very fine granularity the play position as it runs between the big chickens. So the comment even says here, updates the global playhead pause with fine granularity for visualizing the playhead smoothly in Unity. All right. So this means
So essentially, it's telling Unity where the position of the chicken is from Chuck, right?
That's correct. Yeah. So it in fact is doing that. Before it was doing that too, but we just weren't updating playhead pause except every time we get to the next step in the sequence.
Right.
Here we just get a lot more updates between those. So that's a really good point. Anything else before we try running this, Kangwoo?
Let's run it.
Let's run it. How could this not work? That is the rallying cry. Excellent.
There it is.
There it is. You can see from these various views. Let's do the main camera. There it is. Now, this is great. So now we have achieved something really important right here. We have got the audio working, and now we have smooth animation. And the audio and the timing, I'll take care from the audio side, and the smooth animation being informed by the audio side to actually draw smoothly. Okay, I'm really glad that worked.
Yeah, me too.
So where should we go from here?
Okay, now I think we can animate
Ah, yes.
the chickens.
So how are we going to do that? AKA, what code should I copy next?
Yeah.
So I believe we go back to our chicken sequencer file that we've been copying out of.
Mhm.
And
I think we should copy the animator variables.
right. So here are the animator variables, which we neglected to copy earlier. In fact, we specifically, didn't copy those because we weren't there yet. And we're now going to copy them into our program. So we have an animator for the playhead, right? And also something for, and also a time step for the run animation. I believe we're going to now then initialize this in the graphics. So
Right.
I think nope, that's the selector. So we're actually basically going to get a reference to the animator that's associated as a component of the playhead, and we're going to just store it away in this member m playhead. I'm going to do that at the bottom of init graphics.
And the playhead is the small chicken that's running.
Right.
And also our tuned chickens have built-in animations, which means that it has our prefab of the tuned chicken already has an animator component attached to it. But if you're using your own 3D model, you have to attach the animator yourself and create the animations yourself.
So fortunately here, we're going to use whoever made this Megatoon series for the free, for the Mesh-in Free Chicken Megatoon series. They already basically built in the animation and put them as animators into the prefab. So all we have to do is get the animator and then also call and control the appropriate animations. And let's see, let's go back to the code, the original code that we're copying from. And I believe this is the animation update. So I'm going to put anim update. I'm going to call this as basically there's another function that's associated with update. So I'm going to put it right under update here. And I believe we're just going to call anim update. Animate the playhead. Okay, so we have this anim update. And just to briefly explain this is actually the name of the particular animation we're accessing. And here we're actually giving it basically kind of, this is controlling the rate at which the running animation is going to happen, right? So, and this is, we're just incrementing this according to delta time, which is really kind of the duration between successive graphics frames in Unity. Right. Are there any other nuances to delta time in Unity?
I think that's it.
Right. So this is nice because this makes this more robust to different frame rates. Right. So this is basically if you're running this at 20 frames versus 90 frames per second, this will still, the chicken may look choppier in the 20 frames per second case, but the actual position will still be correct, and also as well the rate. So let's see what this looks like. If all goes well, we should now see the chicken actually running. It's kind of hard to see.
I think it is running.
I think it is running.
You can see its wings flapping.
Yeah. Okay, so now we've animated, thanks to the existing default animations that run in place, except it's running in place and we're translating it.
Right.
Cool.
And one note is that there are two things, animator and an animation. And the animator controls various kinds of animations. So yeah, I was confused when I first dealt with animations in Unity, but yeah, there are two different components.
So when we actually got the component from Playhead, we actually got an Animator.
Right.
Right. And am I correct in saying that run in place is actually animation?
Right. That's the animation.
Right. So this is the name of the animation, and then our animator, we're actually using the animator to animate the animation.
Yes. so many animations.
It's very animate. So okay.
Yeah.
Excellent. What now, Kung Wu?
Should we also animate the big chickens?
Yeah, let's animate the big chickens. So whenever the little chicken, the playhead, runs by the big chicken, not only does it go dope, but there's a corresponding animation of the chicken trying to peck at the little chicken or try to eat it.
Right.
So in that case, we're going to go to our code copying place, and we're going to copy this function called eat. And we're going to copy this into our chicken-sir C# program under anim. And really what we're doing here is we're thinking this as a trigger rather than something we are actually controlling the rate of. We're just going to run it at the default rate. And what we're going to do here is make a function that when given the index to a chicken, we're going to get that chicken's animator and use that to play the eat animation. And so the trick is basically like to know when we're going to do that, right?
Right.
So, well, when should we do that, Kung Wu? What do you think?
Yeah, whenever the playhead resets, we should.
So whenever the playhead resets, so to think about this, let's go back to our Chuck code, right? So the playhead is actually here. That's a playhead position. But really, this is the actual logical point in which is being played. That's the current chicken that's making the sound, basically. So you're saying perhaps when this value changes is when that particular chicken should now eat.
Right.
So in that sense, hey, check this out. We have already, the current chicken is already a global int. And it's in fact what's already been connected to in our
int syncer.
It's our int syncer. That's actually current chicken, which means we can actually get at the current chicken anytime we want. And so what we're going to do here is basically this code right here. I wish, it's really nice if when we're programming, there's just like code that magically appears that we can just copy and paste. That would be really nice.
That would be awesome.
That would be awesome. But at least we have it for this tutorial.
Yeah.
Because we already went through this. So, whoops, that's not the place. So this is going into update. All right, let's try to understand this real quick. So this is using the get current value off of this int syncer. That's going to give us the value that's attached to it, which is current chicken, which is that global int in the Chuck code. That's going to tell us what the integer value is for the chicken that's basically just playing. And we're going to have a variable here that we're going to copy in. So there's a current chicken, then perhaps there's a previous chicken. Where's the previous chicken? Here it is. Here's the previous discrete chicken number. These are some of the better variable names that we've had to work with. M previous chicken is a good it's a good thing. So we have M previous chicken. We're going to set that to -1, and that's purely just so when it's 0, we know that this is the first time something should just eat. So now we're saying basically if the current chicken is not equal to previous chicken, and only the first time that's the case, we're going to start the eating animation, and we're going to remember that the previous chicken is now the current chicken. So the next time through the update function, this is not triggering again. We only want this to trigger when current chicken's value actually changes on the Chuck side. So this is yet another way to actually, this is one of many ways to observe state change and respond to it between Chuck and Unity. So let's see if that works. What do you think, Kung Wu? Do you think we have it?
How could this not work?
How could this not work? This is totally going to work. Call us the optimistic coders. Boom.
There it is.
There it is. Great. Beautiful. We have a chicken that runs and that also animates, and we also have large chickens that pluck. All right. So this is kind of really the foundation of this kind of sequencer. Let's see, what else should we do now?
Now maybe we can change the rates and gains, both
Yes.
on graphic side and the audio side.
So for this, actually, let's go to our finished chickencer. I don't think it's quite finished, but let's go to the finished product and actually look at what we're going for once again, just to remind ourselves. So in this case, I'm going to make everything a little softer so we can hear better. All right, so these are some...
Oh my gosh.
Okay. So what we're going for here are two. So Kungwu, you said we want to control basically what we're just controlling here. That's
right.
Control its height, which is also its volume. Control its width, which is also its playback rate. And also we want to animate this little selector thing. That's showing us which chicken we're actually working on.
Mm-hmm.
So that's kind of the goal here. So how do we think about this? What are some best practices we might bring into architecting this between Chuck and Unity?
We can set a float array for each gain and the rate for each chicken.
Mm-hmm. And do you mean that on the Unity side or
on the
Chuck
Unity side?
Okay.
And have those. How do we actually do it?
It's a good question. I'm trying to remember that too. So how do we do this? Oh, right. Here it is.
Okay. We had an array, right?
We did have an array. So in fact, we actually have this whole section called shared sequence. This information is duplicated across Chuck and Unity and is communicated to Chuck using Chuck events. So actually, we kind of tricked ourselves out. The correct answer, according to what we commented before, is that we actually have an array that's duplicated on both sides. One in the C# and the same array in Chuck. But the key part here is I think we actually take the input from the Unity side. Chuck really doesn't even know what a chicken is. It just has this num chicken thing and also the current chicken. And so these could be buffaloes for all Chuck knows. And but then the idea here is going to be told, it's going to have an array, someone's going to tell Chuck the second thing in this array is going to have this playback rate and this volume. And then Chuck is basically just going to render it that way. So the moral of the story here, other than that, is that we're going to actually use the input from the Unity side. and basically use Unity capture keyboard input and store that locally in Unity in an array for the rate and both the rate and the volume. And then we're going to also find a way to tell Chuck that, hey, these values have been updated. Please play the sound accordingly. So I think that's what we have. All right. So I guess the question is, which part should we copy and paste first?
Yeah.
How about, since you were talking about the arrays, let's go ahead and do that.
Right.
Shall we?
Yeah.
So we have here, it's right before this, whoops. Excuse me, I copied incorrectly. And then we're also going to copy the selector. So this is actually telling Unity which one is selected, which chicken is selected for us to edit.
It's the graphical halo on
Yeah.
top of each chicken, right?
And again, Chuck doesn't really care at this point because it doesn't change the sound. That information is purely local to Unity.
Right.
And then we're going to actually now get the selector prefab and copy that in.
Yep, and that's the prefab for the halo.
It's a prefab for the halo. And anything else? Oh yeah, there's also the selector here. I'm going to copy this. And then let's go quickly review what we just copied. So this is all related to this idea of selecting a chicken to edit. And so we have a selector prefab, and we're just gonna basically this is gonna end up being the floating yellow hockey puck or the floating donut without a hole above the chicken. We're gonna have a game object that represents the selector thingy over the selected chicken. And we've also added this shared section, which means that these things are actually meant to be shared within here. In fact, this actually could just go to the graphics side. Which chicken is selected for editing. That's just the number. We have a float array that's mseq rate. This is the sequence rate. So if there are 4 chickens, there are going to be 4 corresponding rates. Similarly, there are going to be 4 corresponding gains that's going to control the volumes of these chickens. So that's what we've added here. And then, let's see, let's go ahead and add input code, shall we? Actually, we need one more initialization.
Yep.
That's this init sequence. We're like the worst tutorial givers here. What should we do next? We have no idea.
Yes.
We forgot. Sorry about that. But this is why we're copying the code. We can't forget totally. We're going to initialize the sequence here. Initialize graphics, initialize audio, initialize sequence. And in initialize sequence, note that we're allocating these arrays to the number of chickens. However many number of chickens we are, we're going to allocate that much. And for each element in these arrays, we're going to initialize both the rate, that's the playback rate, to 1, which is kind of in Chuck, that's 1 playback rate. And for SoundBuff is play at a normal rate forward. We're going to change this, right? If this number goes below 1, for example, to 0.5, it's going to play back at half a playback rate. And in this case, it's like really like slowing down, like, you know, like a tape. And so it's both going to be twice as long, but also the pitch is going to be dropped an octave. And then this gain here is the volume. And I'm going to initialize that to 1, which is, of course, the nominally the kind of the full volume in the nominal volume range for Chuck. So that's init sequence. If we play this now, I don't think anything will be different, because I think we're just dealing with the data structure here. So let's add a bit of input into this. So for this, we're going to go back to our savior script, which is going to remind us what we're supposed to do. And all of this code in this really horrendous if and else structure we have is basically just running through the input to see if we basically have, if these keys have been pressed.
Input of the keyboard.
Right. So this is just from the keyboard saying, did the letter A do we detect a key down from there? If so, we're going to do something, and else we're going to check down here. So if we just look at A and D, remember that was moving the selector left and right to the chicken. So if we're going to move it left, which means we're going to decrement the chicken index. And if we go below 0, we're going to wrap around to the right side of the chicken line. And D is the opposite. We're going to increment it and then wrap it back to 0 if it goes beyond the number of chickens we have. And then similarly, these are my arrows on my keyboard. These are going to adjust both our rate for the left and right, that's making the chickens bigger and smaller, adjusting the chicken's gain, that's making the chicken taller and shorter. And we just need to then now copy these functions, and we might be very close to having the next step.
Yeah.
Here's adjust rate and adjust gain.
Mm-hmm.
I'm really glad we're copying and pasting these functions. Like really long to type. And again, we'll have this code available, so you can basically liberally borrow from and just copy and paste from this code to fit your need. So here's adjust rate and adjust gain. We're just going to look at adjust rate to give you a sense what it's doing. Here, it's going to either be left or right, so we just kind of put, is it a left or is it a right? If so, we're basically make the rate, it's a multiplicative thing, so whatever the current rate is, we're going to make it 90% of that if it's going to the right, which actually makes the thing bigger. It makes it sound bigger, right? Or if it's going to the left, we're going to make that the rate actually faster. And then we're going to clamp these values in this code. And keep in mind, this is the Unity side, between 0.5 and 2. So in this way, the rate can never go below 0.5 and can never go above 2.0. Chuck doesn't know anything about these bounds. This is all purely clamped on the Unity side, which is nice. Chuck, again, is kind of this just rendering the audio faithfully from what Unity tells it. And similarly, Chuck is going to tell Unity, hey, this is where the sequencer is at, where the playhead is at. In any case, that's the actual changing of the arrays. We then take the chicken that corresponds to which chicken we're adjusting the rate for. We're going to scale it accordingly. So here, we're going to scale its local scale on the transform to basically X. That's basically how big or small it is, how wide or thin it is. It's going to be basically this seek rate. We're going to look at what's in there. And then the seek gain is going to be how tall or short it is, right? So that takes care of the graphics. These 4 lines down here is actually what we use to actually tell Chuck that these values are what these new values are, and also to tell Chuck that an edit has happened. So before we run anything, let's go back to the Chuck code, and here we're going to actually go to, this is the final chickensir Chuck code, and we're going to now use this to add to what we have in chickensir. So here what we do is go ahead and copy the edit rate and edit gain. In fact, let me just copy this whole thing. Sorry about that. This is the global incoming data from Unity. Which thing or which chicken we're editing, what's the rate and gain associated with that edit, and also a global event that we're going to listen to for Chunity to tell us that an edit in fact has happened, and we need to take these new rates and gain for this chicken into account. And so let's also copy the code for that part. And by the way, this is the corresponding sequence array in Chuck. Let's go ahead and copy that in. And now, instead of just one, this actually, we've kind of been hacking it so far. We just have one sound buff playing this over and over again. Instead, we're actually going to have chickens number of sound buffs and actually put it through some chicken reverb. So we're going to just replace all of that with an array of sound buffs. We're going to make a reverb, and we're going to set that mix, and we're going to use this particular for loop to then both load up the sound, connect each sound buff to the reverb, and then for now make it so it doesn't make any sound. And I think the only thing that's left here is we're going to do a little bit of editing on the play. So previously we just set the position to 0 to play. We're now going to replace this with a play function that actually plays the current chicken. And that's because it does a few more things other than just setting the position, because now we actually need to take in the rate and the gain into account. So we're actually going to use this array here to play it. We could just put all of this in here, but here we can just put in a function. And remember, these values are really coming from the Unity side, and this is where they end up.
Mm-hmm.
And then I think the only other thing we have to do now is to listen for the edit, which is what this final function is for. And if we look at this function, yet another while loop. So we're going to be running this in parallel with everything else. We're going to wait for the event to say, oh, has that happened? And that's going to be triggered via broadcast from the Unity side. We're then going to take these values and put them into the corresponding elements of these two arrays. We're even going to do a little bit of debugging output. And that's the function that listens for update. So we also need to just spork that function, which we're going to copy again here. So, any bets on whether this is going to work? I've like randomly copied like 20 different things into this. So, yeah, let's go ahead and run this. How could this not work? First of all, am I in the right? I think I'm in the right chicken, sir.
Yes.
So it looks the same, but now we should be able to select a chicken, and we don't see the selector because we haven't drawn it. Aha! So I'm actually pressing D to move to the next chicken, and I'm pressing, you know, kind of the down arrow to it's actually working. Will it work in? Ah, cool.
Oh,
actually,
great.
I'm actually surprised this worked. The copy and paste is so much code.
Wow.
Wow. Yay. We totally meant to do that. Totally thought this was going to work. So this is great and all, right? And we're almost done. But as you can see, it doesn't seem like the best user interface because we don't know which chicken we're actually editing until we edit it. That ain't so good. So as our final act in this tutorial, we're going to draw the selector, the heavenly puck or the donut without a hole above the chicken that is selected.
Right.
How are we going to do that?
So let's create that object first.
Oh, right. And when I say how we're going to do that, I actually don't really know. I genuinely want to know. So let's create the object. And how are we going to do that? So I'm going to create a
3D object.
3D object.
And
cylinder. There it is. Here's that cylinder.
Yep. And first we'll reset the transform. And yeah, let's definitely make it smaller.
Okay. What numbers do we use?
I think 0.1, maybe 0.02. And 0.1. Is that too small?
I'm not sure. That actually looks pretty good.
Okay.
There it is. All right, so we have this thing. We probably should make this, what, a prefab, I'm guessing?
Yeah.
So let's create a new folder, prefabs, and I'm going to just drag this in here. And now we now have this prefab. I'm actually going to delete this. So we're actually just use this as a way to create a prefab. And we're going to instantiate the prefab in code. We'll call this, what do we call this? Is the selector?
Selector,
In fact, let's make it the chicken selector. Not the chuckin, but the chicken selector.
Chuckin.
The chuckin selector. It's a chuck chicken, so it's a chuckin.
Chuckin. I kind of like it.
It's pretty good. Maybe this is a chuckin, sir.
Yeah.
So here we actually now if we go back to the chicken, sir, we see that we've added this selector prefab as up here, and that now we need to tell it what we actually want for that. So in this case, we're going to drag this into the selector.
The selector.
So this is now, we can now access this from inside the code directly, and so now it's time for one last round of copying and pasting. And if I can only find where that is. Here it is. we are going to copy this, and then we're going to explain what it is that we just copied. So I'm going to copy it into the same place. First of all, I guess we're going to get the first element of the chicken array, because that's the default chicken that's going to be selected. And then we're going to instantiate a new game object using the selector prefab. That's our puck.
Uh-huh.
And here we have this gobbledygook code. And this really is a matter of preference as to how you want to do this. The way we were doing this, you want to explain what we did?
Oh yeah, so we took the bounds of the chicken model. So the chicken model has a skinned mesh renderer. It can be a mesh renderer or any other kinds if you're using different 3D models. But if we do render, that bounds, that extents, that magnitude, that gives the radius of the bound of your 3D model. So we use this because when chickens get taller, we want the hockey puck to move with the tallness of the chicken. So we wanted to get the radius of the bound and place our puck there.
Right. So we're trying to get a little fancy with this part, but you can totally do this how, if you were doing something like this, there's so many ways to do this, right? We were just, it's like, I bet if we can get the bounding box, we can do this. And after some round of, I think we Googled and tried things, we found, hey, we can use this. And it still doesn't work perfectly, but it actually works well enough for our purposes. So that's the story behind the selector and why this gobbledygook code here that you totally don't need. And then we just need this function that positions the selector. And it really depends on which chicken is selected. So let me go ahead and just add this code here. Let's see, anim update position selector. So whatever the current selected chicken is, we're going to get that corresponding game object, that particular chicken, if you will, and instantiate. It's not really instantiate the selector now. It's actually translate the selector.
And position selector is getting called every frame, right?
I see. It should be, but it's not. Because we didn't copy that piece of code.
Okay.
Worst tutorial people ever. Here we go. Sorry about that, y'all. Now this will work. How could this not work? Probably in any number of ways, but it's totally gonna work. Yes. So now we see this moving. Also, if we lower it, see the puck kind of going with it. The reason I said it's not perfect is that when the chicken goes to eat, the puck actually goes up. And that actually may be because the radius actually increases, right? We're not using actually the pure bounds. We're actually using kind of the circular bounds as a radius.
Yeah.
So that's why that. But I think.
But I kind of like it.
You kind of like it, right? So I think that's actually a feature, not a bug.
Happy accident.
Happy accident. Totally a feature. And I think there you have it. Anything else? Actually, should we make the puck like something that looks less like just a puck?
Just a 3D object from Unity.
Yeah, let's make it look something that's not just a 3D object from Unity. What can we do? What can we do for that then?
We can make it shiny.
Make it shiny
by making it emit light. So maybe we'll create a new material.
Okay, so this will be our final. For our final act, we will make the puck shiny. It is important. So this is the selector material.
Yep.
All right, what we got here?
And then if you click on emission, actually let's double click on the chicken selector in your projects folder prefab.
Okay.
Yep, and we can attach a selector material to the chicken selector in the hierarchy.
I think it's done.
Or yeah, or you can do
I
that.
think I just did that. Yep. Where's the material?
So if we click on the selector material, I think you're on the chicken selector. So if we go to the selector material, we can check on the emission and then change the color by clicking on HDR. Yep. And in this way, the object actually emits light. So we don't see so much of like the shadows that's caused by the directional light.
Okay. So if we did that,
right,
we should see more of a actual heavenly selector for the chicken. Cool.
Oh, we do see the shadows.
We actually still see the shadows.
In this case, we can increase the intensity of the emission. So if you click on the color again, and below where it says +1, +2, you can increase the amount or the intensity of light it's emitting.
Is that a good number?
Sure.
Okay, cool. Let's try that. I want this to be like a radiant selector here.
Yes.
There we go.
Yeah, and since it's emitting light, if you use post-processing asset and import that into this project, the halo will actually blue light.
It's beautiful.
Yeah.
So at this point, I think this is kind of this is the chicken search tutorial. We will like to reiterate a couple of things, from this. One is the architecting of the sound, the graphics, and interaction. In this particular case, what we've done is to put the timing, the responsibility for keeping musical timing solely within the audio side, that is in the Chuck file, in the form of this loop that's basically has a notion of what a beat, potentially what the basically duration between sequence elements are, and to use that to drive the sound and to drive things that are usable by the graphics, like where the playhead is. So I would say that's takeaway number one, which is always do musical timing from the audio side. Secondly, we kind of have the reverse, right? You can even see kind of these global variables. There are outgoing variables, which is, the current chicken and the playhead position. That means it's being taken care of in Chuck, and then it's going out to Unity. And from Chuck's perspective, there's incoming data from Unity, which is basically all the edit data. So the second takeaway is that in this case, the input, in terms of the keyboard input, to change and select and change the chicken, that's all taken care of from Unity. And then Unity is advising Chuck as to when these parameters are changing, and Chuck will take them into account when Chuck actually deals with the sound. Right? So it's really all state changes that's going in both directions. And these are done using a variety of mechanisms, including the int and float syncers, as well as using events, and also using kind of this set int and set float methods off of the sub instance, which are, then you can basically change the value of any global variable from Chuck in this way, right? Right. Any other takeaways from this?
I think that's it. I always, whenever I implement Unity in the project, I always think audio, graphics, and ways to connect them.
Right. I think that's really
connect them through syncers or set ints or broadcasts. You can use all the tools that Unity provides and make sure that audio is driving the graphics, the timings of graphics.
And by the way, like the way to find out about all this is if you go to the Chuck page, chuck.stanford.edu or chuck.stanford.edu or chuck.cs.princeton.edu, and you click on Chunity. This is the Chunity homepage, and there are tutorials here. These will tell you everything you need to know. Everything we talked about in terms of infloat syncers, set and get, set float, set ints, and also broadcasting events. All of that is actually here in this wonderful tutorial by Jack Atherton. We'll also have this link below for easy access as well. So maybe
another good, if you go back to Chunity tutorial page and go back once, if you click on documentation, it has all the variable names you need that are not necessarily in the tutorial, but in a similar sense. Such, for example, like the tutorial explains on get floats and set floats, but if you want to do set int and get int, you can look at this documentation and implement however you like. So this documentation is awesome.
Yeah, Jack did such a fabulous job with this.
Yeah.
And so this is like the full reference for Chunity in terms of what you can do, especially the communication between Chuck and Unity. So like a combination of the tutorial and the documentation, you should tell you what you need to know. And the rest is really up to you and how you design and implement and architect your system. And maybe the other thing is what we'll reiterate is what we said at the beginning is that this is not even a complete, this is a really simplistic part of a sequencer, right? You could easily think about, for example, if we were to come here and change this 4 to 8, and I did the same thing on the Chuck side, if all goes well here, we can now have basically a 8 chickenser. And all the code we've written actually still works. And of course, like, you can think about how to then scale this up. What if the chickens were in a ring? And that means the little chicken doesn't have to teleport now, and it seems to make more sense. You can easily make it so that the camera follows the playhead. Or maybe it's from the first person view of the poor little chicken that's running, and all these giant chickens are trying to eat the little chicken. You can have multiple lines of chickens or maybe different kinds of animals. For example, if you're making an animal themed sequencer, so you can actually have multiple voices. So this is really kind of a single sequence, single voice, discrete grid-based sequencer. So, but again, the point of this tutorial was to show you how we could architect the timing between the audio and the graphic side. And so it's better to understand that part and then really think about how you want to architect the code to fit your specific need for the kind of sequencer you might want to build. So with that, I think that's all we got.
Yeah.
So, well, everyone, thank you so much for watching this episode of Artful Design TV coding tutorial for the chicken sequencer. We'll be back with more coding tutorial, and a lot more copying and paste will probably be in the future for us to bring you how to actually, different ways to get audio, get graphics, music, interaction, and put them all into this unity, if you will, of kind of an interactive audiovisual design system, right? So this is Kung Wu and Ge. We're signing off. Thank you very much.
Thank you.